Uh, Hello everyone, welcome to this video. In this video, we are going to talk about DevOps and DevOps culture and what is actually is a DevOps and what roles should the DevOps engineer play in their company for a in a project or any project. So let's start. So as you can see in my screen, I have this is an DevOps PPT. I have DevOps handbook. So of my company, so where I work the Leapfrog. So what is DevOps? So Dev refers to an application, software application development, and Ops refers to an IT operation. So DevOps is an hybrid type of job in which you have to do a development as well as an IT operation. So I'm going to thoroughly read the presentation. So let's go. To simply put it, DevOps is a culture, not a role. The whole company needs to be doing DevOps for it to work. AWS defines DevOps as a combination of a practice that increases an organizational ability to deliver application and services at high velocity. It helps to enable organization to serve their customer better and complete more compete more effectively in the market. Under DevOps model, the development and operation teams are merged into a single team where the engineers work across the entire application lifecycle, from development and test to the deployment to operations, and develop a range of skills not limited to a single function. So yeah, so in a DevOps you have to code, plan, and then monitor, release. All these tasks should be done in a DevOps. So as you can see in a diagram, you have to code, plan, build, test, release, deploy, operate, monitor. All these things should be done. So yes, so let me go to the next slide. So who do we adopt a DevOps? How do you adopt a DevOps model? So in order to adopt a DevOps model, you have to be you have to know some of the technologies and some of the good practices that are being used in a current scenario, current industry, such as infrastructure as code, containerization, and config management, CI/CD, logging and monitor, all these, and you should using the right you should be using the right services. Yes. So, so let me talk about the infrastructure as a code. So, what does an infrastructure as a code means? So, infrastructure as a code, what does it means is that, for example, currently we are using Terraform. There is a Terraform as an infrastructure as code. So, what Terraform does is that simply we write resources, what we need to be deployed in our cloud. So in a code format, for example, I am writing I need an EC2 instance in an AWS cloud. So I will write an Terraform .tf file, example main.tf, or yeah, main.tf. So in the main.tf I will write resources required EC2 instance. So I will give name and I will do Terraform apply. Then it will take an AWS credentials stored in my system and will deploy uh, EC2 instance in the cloud. So how it will help to this is a simple example I am saying. So it will help you in the case of a lot of an infrastructure. If you create an infrastructure in a cloud like AWS, Azure, or Google Cloud manually by clicking, then you won't be able to keep the track of and resources. After all, we are a human, so it won't be perfect that something you may forgot to delete the infrastructure after your project has been complete. But if you have delete, then the billing of the that resources will be continuing. So you have to uh, pay for that resources. You can't say that no, I forgot. So it doesn't work that way. So if you create an infrastructure with the Terraform and other infrastructures, So it other infrastructure as a code services such as Ansible is also there. Terraform is there. There is cloud formation for AWS, specific for AWS. Terraform supports most of the cloud services like AWS, Azure, Google Cloud, Heroku, and all. Yeah. So infrastructure as a code is an important because it helps you keep the track of and all the infrastructure, and if and all the dangling resources can also be deleted. So yeah, this is all about infrastructure as a code. So let me go to an containerization. So what does containerization means is that containerization is, and simply we know what Docker is and how Docker is being used. So containerization is just packaging of resources, packaging of your software package so that it can be shifted anywhere, and it work fine in every environment. So it doesn't hamper the environment. So later, before uh, before the invention of containerization, there was a myth or a problem that developer says the code and application is running fine in my system, but I don't know why it is running in his other system. So this is a big problem. So container after the invention of a containerization and a Docker, so what we can do is that we can package a container. We can package we can create an image of an container, so with all the necessary dependencies required for running an application, and we can just shift that application to another system, and we'll can just run that container, run that image up, so that we can get all the dependencies required in a one package format. So if I run the image from run a container from that image, and then all the dependencies have already been installed, so there is no any issues of that the code is running fine in my system, application is running fine in my system, not in his system. So this problem has been solved. So container in the cloud, there is an AWS Fargate, and Amazon EKS is a Kubernetes service. Fargate is an also a cluster type of container service in the AWS. So we'll be talking about that in a later in the class. So other is an config management. So config management, in the config management, what we do is that all the resources and all the our sacred files are kept in an such config management system such as AWS Secret Manager or SecOff Vault, so that our our applications is secure. Because for example, if I put my credentials of a database in .env file, and we will not push that .env file to the Docker hub. So because .env file will contain the credentials of an AWS database. So those credentials are critical, so we have to store those credentials in AWS Secret Manager or in Vault, and Vault AWS Secret Manager, and we can or in a Vault as well. So we can retrieve those information from the AWS Secret Manager or Vault in our in the in our CI/CD tool, so that uh, from where we will be getting the environment variable, and deploying our application with required credential without without exposing these variable in a GitHub, in a public repo, all these kind of stuff. So config management is that. So let me go to an CI/CD pipeline. So CI/CD generally means continuous integration and continuous delivery. Continuous integration is a software development practice where developer regularly merge their code and change into a central repository. Means small changes in the code should be merged in an production or a master branch, so that it reflect the changes, and small testing can be done. So continuous delivery means continuously deploying, and is a software development practice where code changes and automatically build, tested, and prepared for a release. So when you push a code, it will trigger uh, CI server, and it will clone all the git clone to your CI server. Then it will test your code, and it will run build, and it will release your code if there is no any an error. And if any errors have been seen, then it will send you an email as well. There is such kinds of services as well. So now this is CI/CD. So we will be talking this about this very soon in the course. So and there is a logging, monitoring, and alerting. So logging, monitoring, and alerting is very important, because uh, logging and monitoring and alerting helps you to know the current status of your system, and helps you to give the correct information about the system. So logging means, uh, let's talk about, you are deploying any application, and you need to check the logs. What logs has it been producing, uh, uh, what is the current situation and current performance of and a system can be monitored by monitoring tools, and all the alarms and alerts can be added, so that if the system reaches this much of an CPU or RAM, then it should give an alarm or message to a system admin or a DevOps engineer. So all these kinds of logging monitoring tools can be used. So here we will be learning about elastic stack, E, EL, ELB, yeah, ELK. Everyone should have read somewhere that ELK stack means elastic stack, log stats, and Kibana, which are three tools used for logging. So I will tell you about these in a detail in my videos, coming up videos. So stay tuned. So lastly, in a monitoring, I have showed that in a monitoring there is a Grafana, NodePing, and all other tools, Datadog, all other tools you can use. NodePing have different type of features and monitoring tools, which check your system usage, RAM usage, CPU usage, and inform you. So it can be all the reports can be imported in a elastic stack, and elastic stack can be uh, data of elastic stack can be given to the uh, in a kibana, so that we can visualize the data. And choosing the right tool and services, it is an important to choose the right tool and services according to your project needs. So you should choose the right tool for for a project, so that it can be effective. So other configuration management language such as Ansible can also be used for and changing configurational files in a different system from one system to hundreds of systems, so that you don't have to manually go to each system and change the file. So yeah, this is all about DevOps, and I hope this video was informative to you guys. And if you like this video, please share this video with your friends and colleagues who are interested in DevOps, and please give this video a like button, and please subscribe to my channel for more such content. I will be producing such contents regularly, and I will be teaching you guys what I know, so that knowledge sharing is and caring. You all know that. So yeah, thank you for watching this video, and hope you have a great day. Thank you.